Today, we're going to learn a new language. But nope, it's not Spanish or Mandarin. It's a language that helps us describe the world around us, the entire universe, really. We're talking about the language of mathematics, and we're going to figure out how to translate our everyday words into its powerful symbols. I mean, just think about that for a second. What if you could literally speak the language of the universe? It sounds like something straight out of science fiction, right? But it's so much closer than you think. Because that's really what math is. It's this powerful, universal language that lets us describe how things work with perfect precision. You know, we use English to talk about our day, to tell stories, to share all kinds of ideas. But sometimes we need something more specific, something more logical. And for that, humanity has come up with all sorts of specialized, you could call them artificial, languages, each one designed for a very specific job. Think about it, right? Musical notation lets a composer from centuries ago speak directly to a musician today, telling them the exact melody and rhythm. Morse code can send messages across oceans with just simple dots and dashes. Well, in that exact same way, mathematics is a language. It's designed to express logic and patterns and relationships with absolutely zero ambiguity. Now let's be real, translating our normal thoughts into this abstract math language, it can be tricky. It can be a real hurdle for a lot of people, but that is exactly what we're here to do today. We're going to demystify that whole process and show you how to become a fluent translator. So every language, it doesn't matter if it's spoken or written, it starts with the basics, right? It starts with an alphabet. And math is no different. Its fundamental symbols are the building blocks for literally everything else we're going to cover. And here it is, the alphabet of math. You've got your numbers, which we call constants because, well, their value is constant. It's fixed. You've got operation symbols, the things that tell us what to do. Add, subtract, you know the drill. We've got grouping symbols, like parentheses. And then we have the really interesting part, letters. In math, we call them variables, and they're just super convenient placeholders for a number we either don't know yet or a number that can change. Okay, so when we start combining these symbols from our new alphabet, we start forming the words and phrases of this language. We call these things mathematical expressions. Now, an expression isn't a full sentence. It's not saying this equals that. It just represents a single idea or a value. It's kind of like the phrase, the total of 5 and 10. And you'll see two main types of expressions. Over on the left, you have a numerical expression. It's made of, you guessed it, only numbers. So it has one single unchanging value. But on the right, we have an algebraic expression. This one has variables, those letters we were just talking about. And that makes its value flexible. It can represent an idea for pretty much any number we decide to plug in. Great. So we have an alphabet, and we can make words. But to make any sense, every language needs grammar rules. I mean, if I said, store I to the go, you'd have no idea what I was talking about. Math has grammar rules for that exact same reason, to make sure that everyone everywhere reads an expression the same way and gets the same answer. And here they are, the famous order of operations. You might remember this from school as PEMDAS or maybe BODMAS. First things first, you handle anything inside parentheses. Then you deal with any exponents. After that, you do multiplication and division, just working from left to right. And finally, you clean up with addition and subtraction, again from left to right. This strict order is the grammar that makes sure a complicated expression has only one correct answer, period. So, we've got the alphabet and we've got the grammar. Now it's time for the really fun part, putting it all together. This is where we actually start the conversation, where we become translators who can turn everyday English into clean, powerful math. And like any good translator, we're going to start with a dictionary. It turns out a lot of common English words have a direct mathematical equivalent. When you see some or more than, you're thinking plus. If you see difference or less than, that means minus. Product, that's just a fancy word for multiply. This little dictionary right here is our key to cracking word problems. Okay, let's try it out with a real-world example. So Masha watched 150 videos. Lena watched 13 times more than Masha. The question is, how many videos did they watch in total? How do we take this everyday sentence and turn it into the language of math? Simple. We just break it down piece by piece. First, what do we know for sure? Masha watched 150. Got it. Next, let's translate the phrase about Lena's videos. Our dictionary tells us 13 more than Masha is just 150 plus 13. Easy enough. Finally, the question asks for the total. which means we need to add Masha's and Lena's videos together. And there you have it, one single, clean numerical expression. And once we have that expression, all we have to do is apply our grammar rules. Following the order of operations, we solve what's in the parentheses first. 150 plus 13 is 163. Then we add that final 150, and we get our answer, 313. See? The language of math gave us a clear path to the solution. Okay, this is where it gets really cool. This is where math goes from just being a tool for solving one-off problems to becoming a way to describe universal truths. This is the leap from just speaking in simple phrases to, well, to writing poetry. So let's imagine a really practical problem. You're redecorating a room and you need to buy some new flooring. To do that, you have to know the area of the floor. Sure, you could go measure the length and the width and multiply them. And that works for that one room. But what about the next room and the one after that? This slide shows the elegance of math perfectly. On the left, we've got this long, kind of clunky English sentence. And on the right, the mathematical translation, A equals L times W. Did you notice that equals sign? This isn't just an expression anymore. This is a formula. It's a complete mathematical sentence that states a universal truth. This one powerful little sentence can tell you the area of a door. It can tell you the area of a book cover or the area of a massive soccer field. One single formula can solve an infinite number of problems. That's not just translation anymore. That, my friends, is fluency. So what's the big takeaway from our little journey today? Well, we've seen that math is a language, a tool for describing our world with total clarity. We learned that variables, those letters, are what give this language its real power, letting us write rules that are true for any number. We practiced translating words into expressions to solve problems, and we found out that formulas are the grand sentences of math, elegant truths that apply absolutely everywhere. Think about it. Every bridge, every skyscraper, every computer, every single spacecraft was designed and built using this language. It's a language for creation, for discovery. So the question isn't really about solving for X in a textbook. The real question is, now that you're learning to speak the language of the universe, what will you say with it?